A very good morning to all. I am Sherry from Department of Computer Science and Engineering. Today I am going to talk about the topic logic gates. The contents of this video is introduction, Boolean algebra, operators, truth table, logic gates, and what are the methods for minimizing Boolean expressions. So, what is Boolean algebra? Boolean algebra is a branch of mathematics and it provides some set of operations and rules to manipulate or process the binary variables, because the system only knows the binary values, that is zeros and ones. So, to process those variables, we need some set of operations and rules, right? So, with the help of this Boolean algebra, we do this, okay? So, Boolean algebra is based on binary number system. So next is the logical operations in Boolean algebra. It is used to perform the logical operations in digital computer. That means Boolean algebra is used to perform the logical operations. Okay. So in digital computer, 2 represent by 1 and the false represent by 0. If we are getting the true value, we represent it as by 1. If we are getting the false value, we represent it as 0. So, logical operations are performed with the help of logical operators. Okay, fundamental logical operators. First one is AND operator, second one is OR operator, and third one is the NOT. So, the AND is also known as conjunction, and OR is also known as disjunction, and NOT is known as negation or the complement values. So, the first one is the AND operator. So, it performs the logical multiplication and it is denoted by the dot. Okay. So what is AND operator? AND operator is just simply performs the logical multiplication. So in normal multiplication, what we do? 0 into 0 is 0, and 0 into 1 is 0, and 1 into 0 is 0, and 1 into 1 is only 1. If both the inputs are true, then only we get the true. That means 1. Otherwise, we get the answer as 0. Okay, this is a truth table for the AND operator. Once again, I am telling 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, and 1, 1 is the 1. Next one is the OR operator. It performs logical addition and it is denoted by plus. Okay, so OR operator simply performs the logical addition. That means 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1, 1 is 1. So, what we can see here, if any of the one input is true, the output will be true. Okay. If the two inputs are 0, the output is, the one value is true, the output is true. Next one is the NOT operator. It performs logical negation and it is denoted by bar. Okay. So, here the NOT operator only operates on one single variable. That means if you give 0, it gives 1 as the output. If you give the input as 1, it will give the output as 0. That's why we call this complement. Okay. So next is the truth table. So what it is truth table? Truth table is a table that contains all possible values of logical variable statements in a Boolean expression. We already see that how we to write the truth table for AND, OR, and NOT, right? So truth table represents the input values and the output values. Okay. So in a truth table, how to find the possible number of combinations? The formula is 2 power n, where n represents the number of variables used in a Boolean expression. That means how many inputs you are giving. Okay. According to that, the truth table combinations will appear. Clear? So this is the truth table for the Boolean expression x, y plus z. Okay. So x, y, z, then x, y, then x, y plus z we have to find it. Okay. So what is the decimal values? 0, 1, 2, 3, 4, 5, 6, 7. So 8 values. Why? Because 3 variables are here, right? X, y, and z. So 2 power 3 we get 8 set of combinations. Okay. So we write the decimal values from 0 to 7. Okay. So next is the two terminologies that we have to learn. Okay, first one is tautology and the next one is fallacy. If the output of Boolean expression is always true or 1 is called tautology. That means if your output is 1, that means true, we call it as tautology. Okay, then your output is false or 0, we call it as fallacy. So next we are going to study about the logic gate. A gate is a digital circuit which operates on one or more signals and produce single output. So what? Digital circuit. So logic gate is simply a digital circuit that operates on one or more signals. Okay, then it produces the output. Gates are digital circuits because the input and output signals are denoted by either 1 or 0. Okay, so the inputs are represented by either 1 or 0. Why? Because system only knows the binary language, right? So there are the three basic gates. First one is AND gate, OR gate and NOT gate. So first one is the AND gate. So I already told that AND gate works as the symbol multiplication, right? So AND gate is an electronic circuit that gives a high output only if all its inputs are high. In normal multiplication, what we learn, 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0 and 1 into 1 is 1. So same concept is here. AND gate only gives high output only if all its inputs are high. AND gate takes 2 or more input signals and produce only one output signal. So this is the notation for the AND gate and this is the truth table for the AND gate. Okay, 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0 and 1 into 1 is. Next one is the OR gate. So OR gate, it works as symbol addition, right? So OR gate is an electronic circuit that gives a high output. That means 1 if one or more of its inputs are high. OR gate also takes 2 or more input signals. Okay, it takes 2 or more input signals and produce only one output signal. Okay, simple addition. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1 and 1 plus 1 is 1. Okay, any of the input is true, it gives the output as true. This is the notation for the OR gate. Next one is the NOT gate. NOT gate is an electronic circuit that gives a high output if its input is low. Okay, if the input is low, it gives the high output. NOT gate also known as what? Complement, right? So NOT gate takes only one input signal and produces only one output signal. The output of NOT gate is complement of its input. That means if your input is 0, it gives the output as 1. If the input is 1, it gives the output as 0. This is the notation for the NOT gate. Okay, it is called as inverter. Next, we are going to learn about the practical applications of the logic gate. So first one is the burglar alarm, right? So while going to the house, we set the alarm switch and the burglar enters, we set the person switch, right? And the alarm will ring, right? See the picture, there a person sensor is there, alarm switch is there, it is connected to the AND gate and the burglar alarm is as the output, right? The electronic door will only open if it detects a person and the switch is said to be unlocked. Okay, the microwave will only start if the start button is pressed and the door close switch is closed. Okay, so AND gate means 2 inputs should be in on condition and only we will get the output. So next we are going to learn about the remaining gates, NAND, NOR, XOR, XNOR gates. So next is the NAND gate. It is also known as the universal gate. Why? Because Any digital circuit can be implemented with a NAND gate. Only with the help of NAND gate we can easily design a digital circuit. Not only NAND, node is also known as the universal gate. Both NAND and node are also known as the universal gate. With the help of this gate, we can easily invent any kinds of circuit only with these two gates. So first one is the AND gate. So this is the symbol for the NAND gate. Okay, one bubbled and is called as NAND gate, right? See the truth table, 0 into 0 is 1, 0 into 1 is 1, 1 into 0 is 1 and 1 is 0. If any of the output is true, then we will get the output as true. Okay, if the two inputs are true, then we get the output as false, right? This is the truth table for the NAND gate. So next one is the NOR gate. This is the symbol for the NOR gate. This is truth table, 0 into 0 is 1, 0 into 1 is 0 and 1 into 0 is 0 and 1 into 1 is 0. Okay, Z is equal to negation of X and Y. Okay. So next one is the exclusive OR gate. This is the symbol for the XOR. See the truth table, 0 into 0 is 0, 0 into 1 is 1 and 1 into 0 is 1 and 1 into 1 is 0. Okay, so any of the input is true, then only we will get the output. So this is the truth table for the exclusive NOR gate. See the truth table, 0 into 0 is 1, 0 into 1 is 0, 1 into 0 is 0. If only two inputs is equal, then I will only get the output as 1. This is the symbol for the X NOR. Okay, that is equal to X negation of Y. Okay. So that's all about the video. Next class we will learn the another topic. Thank you.